Hello friends, I welcome you all to this session on numerical methods using C++. So in today's lesson what we'll do is we'll try to explore another method which is again a bracketing method for evaluating the roots of any equation. Now this method is called as bisection method, and the reason is very simple, that you must be having some bracket, and in this bracket you should be finding the roots. So now, what is the guarantee that we should be getting a root? If this is a curve of the function and it intersect at this point, let's say this is my xr root, then if the function intersects the x-axis, then that is the root. Okay, and if I'm having, or if I'm given this particular interval, and I want to know that whether root exists in between this or not, what I have to do, I have to find out the value of the function at a and the value of the function at b and multiply it. If this difference comes out to be less than 0, or if this multiplication comes out to be negative, then it is obvious that a root will be there, because the curve will be intersecting the x-axis in between this particular interval if this thing happens, because on the left hand side it is positive, on the right hand side it is negative. Or if this is not the curve, let's say this is the curve, let me use different color, let's say this is the curve. Okay, and I am interested in knowing that whether there are any root or not in between these two, then again I have to see that what is the value of function at those points, and it came out that the values when multiplied, it is giving us a negative result. That means they are opposite. The values, the value of the function is different, opposite on to these bounds, that means a and b, and hence we can say that the root will be existing. Now if we take the similar thing, now this is my function and my these bounds happen to be here. Let's say this is a and this is b, and I want to know whether the root exists in between a and b. Certainly not, because if I try to find it out, what is the value of function here and what is the value of function here, they both have the same sign. So if I multiply, then this will be more than 0, that means a positive. So the signs of the value of the functions at those two extremes should be different, then only I must be assured that the root will be there. So what is bisection method? So the first thing is you have to check whether the root exists between those limits or not. Once this is known to you, then what you have to do is you have to bisect it, means cut it into half. What? The interval. So I have taken this figure again and enlarged it for your understanding. So if I cut this function into half, then let's say this is the point. Let's say this is mid. What is mid? It is nothing but the half of this interval. Now, what I do is I evaluate the value of the function at this point again. Okay, and this will be fxm. Now, if fa times fxm is less than 0, as the picture is showing us, if it happened to be less than 0, then it is certain that root will be in between a and xm, not in between xm and b. So what we have to do, if this is true, then our a will remain the same, no problem, but our b will now becomes xm. So xm will be taking the charge of b, or xm will now be replaced by, or b will now be replaced by xm. And if this thing is false, that means they are not on the same side. So let us take another example of this particular scenario. Let's say this is my function, this is the one, and this is my bracket, that is a, and let's say this is b. So initially, if I evaluate it, then I will be able to see that the function changes its sign. Fa is positive, Fb is negative. If I multiply, I will be getting a negative value. Okay. Now, if I evaluate the mean part, so let's say this is the mean, mid part, then this is my xm. And now, if I try to evaluate what is the product of fa times fxm, now this will come out to be 0. That means the curve is on the same side for between these two limits a and xm. That means what? That means the root will not be in between a and xm. Then it should be between xm and b. So if that is the case, then if this is not less, if it come out to be positive as this is the one, then what you have to do, the root will be lying here. So your left limit will becomes xm and your right limit will remain as such. Once this has been done, then you will be evaluating the difference between the two values, or you can also check that whether the value of the function at xm is less than certain limits, let's say 10 to the power minus 5 or 4, whatsoever is your converging criteria. If this thing happens, then you have your answer. Okay. Otherwise, what you have to do, you have to repeat these steps. Again, you have to find out xm and so on. So the logic is very simple. The logic says what? The logic says this. First, you should have one function, okay. Then you should supply the limit, okay. Then you should be checking whether the value of this function at a and b, they are differing in sign or not. If it is no, then you have to stop. If it is yes, that is true, then what you can do? You can evaluate the mean. Once mean is evaluated, then you check whether fa times fxm is less than 0 or not. If it is true, then you do what? Then a remains as such. You needn't have to change a. What you have to do is you just have to change the b part. So b will now be xm. If this thing becomes false, then what? Then what you have to do is you have to change a and replace it by xm. Once this thing is done, then you have to check whether fxm is less than 0, means it is the, or what you can do is you can also do this instead of because you have to see whether it has reached this value or not. So what you can do is you can evaluate the difference between a and b also. If the difference between a and b shrinks, then also you can say that you have got the answer. So in this case, if this xm, magnitude of this, basically, if this magnitude is less than 10 to the power minus 5 or 4, whatsoever is your converging criteria, then you have your answer. If not, then you have to repeat the whole process. That means then if it is true, if it is, this is only for true condition, else you have to move back to this step. Or converging criteria you can also evaluate by finding out this. If this value is less than 10 to the power minus 5, then you have your answer. because in this condition what will happen, a and b both will coincide at the same point, and that is your root. Okay, so you can proceed this uh, with the loop so many times till the convergence is arrived at. So this is what we call as the bisection method for finding out the root, and this is a bracketing method. So in the next lecture we will see that how to write a code for this bisection method in C++. So in this lecture till this point only, thank you very much for watching it.